to Senior Beginner Session 6. Today we are going over ratios, conversions, and rates. So we're going to go over 6 topics. We're going to look at what is a ratio, multi-way ratios, proportions, conversions, speeds, and other rates. Let's start with what is a ratio. So a ratio is a way to compare two groups of data or two items of data. So for example, let's say in a class that we have 10 girls and 7 boys. The way you would say this with a ratio is that there are 10 girls to 7 boys. And there's 3 ways to write this. 10:7, 10 to 7, and finally with a fraction, 10 over 7. So what you're trying to say is that there are 10 girls and 7 boys. So there's more girls than boys. Now, a really important thing about ratios is that you only use ratios to compare. They don't tell you the actual amount. So in this example, they did tell you the actual amount. There were actually 10 girls and actually 7 boys. But if you look right here, our ratio is 2 girls to 3 boys. That doesn't mean that there's only 2 girls and 3 boys in the class. That just means that there's 2n girls and 3n boys, and we don't know what n is. So in reality, we could actually have 24 girls and 36 boys. But then you would write this in ratio form, like this, 24 over 36. But then you would simplify that and actually get 2 over 3. And this is our actual simplified ratio, 2 girls to 3 boys. So now let's look at simplifying ratios. So ratios behave just like fractions. When you're simplifying a ratio, it's just like simplifying a fraction. Let's look at these examples. 2 to 10. So the first thing I'm going to do is turn it into fraction form, 2 over 10. Then I'm going to simplify, just like I do with the fraction. So I just divide this by 2, divide this by 2, I get 1/5, and I can write it again like 1 to 5 or 1/5. Now we have 1/2 to 1/3. So first thing I'm going to do to convert it to fraction form, which is 1/2 divided by 1/3, same thing as 1/2 times is the reciprocal, which is 3 over 1, I get 3 over 2. Then I can leave this as 3 over 2 or write it with 3:2. Finally, we have 1.4 to 2.4. So you want to make sure that your answer is in whole numbers, like each the numerator and denominator is a whole number. So first thing we're going to do is divide by 0.2. So I divide this by 0.2, I get 7, and divide this by 0.2, I get 12. So 7 is 12, or 7 over 12 is my answer. Now let's look at word problems. Let's look at this example. The ratio of cats to dogs in the pet shop is 2 to 5. That means there's 2 cats to 5 dogs. If there are 25 dogs in the shop, then how many cats are there? So to solve this, first thing I'm going to do is write the ratio that I do know, which is 2 cats over 5 dogs. Notice I'm writing it in fraction form. Then I'm going to say it's equal to x cats, because I don't know how many cats there are, over 25 dogs, and I know how many dogs there are. So now what I'm going to do is do just like what we do in session 5, we are going to isolate the variable. So how do I do that? Well, since there's a 25 over here divided by 25, I'm going to multiply by 25 to get rid of it. And I have to do whatever I do here to over here. And then after I simplify, I get 10 cats as my answer. And that is how you solve word problems. Remember, put x or put some variable for the unknown. So if 2 quantities are in the ratio a to b, then the first quantity makes up a over a plus b of the whole, and the second quantity makes up b over a plus b of the whole. Let's look at an example. A 10-foot long rope is cut into 2 pieces whose lengths are in the ratio 1 to 4. What is the length of the longer rope, or the longer piece? So, first thing I'm going to do, I drew a little piece of rope right here, and I have a shorter piece and a longer piece. And I know that the ratio is 1 to 4. That means that the shorter piece is going to be 1 over, or a over a plus b. So 1 over 1 plus 4, which is 1/5. So I know the shorter piece is going to be 1/5 of the whole thing. And I know that the longer piece is going to be 4 over 5. 1 plus 4 is 5. So it's going to be 4/5 of the whole piece. And I already know the whole thing is 10 feet long. So what I'm going to do is just multiply 4 over 5 times 10. And what does that get me? Simplify, simplify. This gives me 8. So I know that the longer piece is 8 feet, and the shorter piece is 2 then. Next, let's look at multi-way ratios. So ratios can actually compare more than 2 quantities. For example, let's say we're at a pet shop, and there are 9 geckos, 12 iguanas, and 21 snakes. So we would say the ratio of geckos to iguanas to snakes is 9 to 12 to 21. But we're not done yet because we have to simplify. And we can simplify by dividing each one by the greatest common factor. For example, right here, we have 9 geckos, right? So 9, 12, and 21, I know the greatest common factor is going to be 3. So divide this by 3, I get 3 to 4 to 7. And that is our final simplified ratio. Now let's look at this example right here. 8 to 32, 4 to 8. So I'm going to divide by the greatest common factor, which is 4, and I get 2, 8, 1, and 2. And that is our final answer. Now let's look at this word problem. So a bowling tournament pays out prizes to the top 3 players in the ratio 5 to 2 to 1. So this is first, second, and third. If the total prize money is $1,000, then how much does the first place winner receive? So to figure this out, first thing I do is find out the total prize money, which is $1,000, and we already know that. So that makes it easier for us. $1,000. And then what I'm going to do is, since I know that whatever this person gets is going to be 5 times the amount of whatever this person gets, and this is going to be 2 times the amount of whatever this person is going to get, I'm just going to add the variable x and try to find what variable x is. So I'm just going to add 5x plus 2x plus 1x, which is just x. And I know that if I add all these together, it's going to equal 1,000. So if I add all this up, it's going to be 8x equals 1,000. Then I solve for x, and x equals 125. But I'm not done yet, because that is just x. That's just 125. That is what the third place person would get. What I'm trying to find is what the first place person is going to get, which is 5 times that amount. So what is 125? So we have, and our final answer is going to be 625, because 5x is going to equal 625. And that is our total prize money, $625. Now we're going to look at proportions. So proportions are when 2 ratios are equal. Now we already used a proportion before in this video for our cats and dogs problem, where we had 2 to 5 cats to dogs. So 2 cats to 5 dogs, and we're trying to find how many cats there were if we had 25 dogs total. So we put 2 cats over 5 dogs equals x cats over 25 dogs, and we found x, which was 10. That is exactly how a proportion is used. Let's look at this example right here. A recipe calls for 2½ cups of flour and 4 eggs. If only 3 eggs are used, then how many cups of flour are used? So right here, we're going to set up a proportion, which means that we're going to have one fraction equal another fraction, or one ratio equal another ratio. And usually the second ratio has an x in it, or any variable, because we don't know what that variable is supposed to equal until after we solve. So right here, I put 2½ cups, because that's how many cups of flour we need, over the amount of eggs we have. So 4 eggs. And I made it equal to x cups, since we don't know how many cups of flour we used, over 3 eggs, and we already know how many eggs we used. So remember, you always want to make sure the same units are across from each other. So eggs, eggs, cups, cups. Now what I'm going to do is isolate the variable, and to do that I have to multiply by 3 on both sides. So I multiplied this side by 3, which canceled out the 3, and I multiplied this side by 3, and I got 15 over 2 over 4, which then is equal to 15 over 8, which is equal to 1 7/8 cups. So that's how many cups of flour are used. Now let's look at this example. My yearbook picture is 3 centimeters wide and 5 centimeters tall on my phone. I want a larger picture that has an area of 135 centimeters. What should the width be? So for this one, we have a ratio right here, 3 centimeters to 5 centimeters, and that's from the width to the height. So I know that if I multiply the width and the height, I should get the area, right? So that's what I'm going to do. But I'm going to put the variable x in it, because we know that for a ratio, we know that if we put an x, the ratio is the most simplified comparison. So I put 3x times 5x, which equals 135. Then I got 15x squared, which equals 135. Then I got x squared equals 9 by dividing both sides by 15. And finally, by taking the square root of this side and taking the square root of this side, I got x equals 3. But that's not over, that's only x. Now I have to actually find the width. So I take this x and plug it back into here, 3x. So then I get 3 times 3, which equals 9. So now the width has to be 9 centimeters. Next, let's look at conversions. So for conversions, basically you're trying to convert from one unit to another. For example, you might want to go from yards to inches, or from feet to inches. Maybe even go from inches to millimeters. So let's look at this example right here. We are going to find the amount of inches in a yard. Now, I know you might already know, but we're going to use these two methods to find out. So the first method is using the ratios. If you look right here, we know that the ratio of inches to feet is 12 to 1, since there are 12 inches in 1 foot. We also know the ratio of feet to yards is 3 to 1, since there are 3 feet in 1 yard. Now what we're going to do is try to make the middle the same, to make it into a multi-way ratio. See right here, the feet, right here, 3, 3. So to do that, we're going to multiply this side by 3 and this side by 3. So we get 36 to 3, and here we already have 3 to 1. So now we can just combine this since they're the same, feet, and just say that 30 inches to feet to yards is 36 to 3 to 1. And since we know that there is 1 yard, we know that there's 36 inches. And so we know that there's 36 inches in 1 yard. So the main thing for this method is to make the middle the same. Now let's look at this method right here, method 2. This method uses something called conversion factors. So if you look right here, we are putting this ratio right here in fraction form. So we have 12 inches over 1 foot. And we're going to multiply that by 3 feet in 1 yard, which equals 36 inches over 1 yard. Now this makes sense because when you multiply these things, the units cancel out. If you look right here, we have feet down here and feet up here. So when you multiply them, they end up canceling out. And whatever's left is inches over yards. And we have 12 times 3, which is 36 over 1. So 36 inches over 1 yard. So the main thing for this right here is to have whatever you want to know, inches, in the end. So let's look at this method right here. This method uses something called conversion factors. So if you look right here, we are writing this ratio but in fraction form. 3 feet is 1 yard, so 3 over 1, times 12 inches over 1 foot. So the main thing about this method is you're trying to cancel out the units. So when you have feet on top and feet on bottom and you're multiplying them, you know that they cancel out because it's just going to be equal to 1. Since like let's say 1 over 1 equals 1. Now what you have left is inches over yards. And we have to multiply by 3. So 3 times 12 equals 36 over 1 yard. So we know that there are 36 inches in 1 yard. And a really important thing about this is that we want whatever unit that we want in the end, we want it to be our last conversion factor. So we want inches, and we got inches right here. And we want to make sure the units cancel out. So the main thing about this method is that you're going to use conversion factors, and you want the units to cancel out. Now usually you want your conversion factors over 1. For example, 3 feet over 1 yard, 12 inches over 1 foot. You can also use a reciprocal. 1 foot is 12 inches and 1 yard is 3 feet. Next, let's look at speed. So speed is the measure of how fast something is moving. Right here, something is moving 40 miles per hour, which means that in 1 hour, it's going to drive 40 miles. So a really important note is that speed is the ratio of distance to time. So that means that speed equals distance over time. And you can rearrange this to find the unknown. Let's say you know the speed and the time, but you don't know the distance. Well, then you're going to isolate the variable, which is here is distance, and you're going to multiply by time and speed together to get distance. So speed times time equals distance. And you can also say that distance divided by speed equals time. Let's look at these examples. Let's say you're driving 110 miles in 2 hours. What's your speed? Well, first, we're just going to divide the distance by the time. 110 divided by 2. And then this right here means miles per hour. And then we simplify, and we get 55 miles per hour, and that is your speed. Now let's say we know your speed and your time, but not your distance. So we know that you're going 70 miles per hour, and you're driving for 2 hours. What distance are you covering? Well, as you know, you want to isolate the variable. So multiply this by 2, multiply this side by 2, and you get x equals 140 miles. Next, let's look at this example that uses average speed. So Shelley drove the 50 miles from her home to her office at an average speed of 75 miles per hour. Coming home, she encountered heavy traffic and drove the same 50 miles at an average speed of 50 miles per hour. What was her average speed for the entire 100-mile round trip? So something that's really important is that for this average speed, you cannot just add 50 miles per hour and 75 miles per hour and divide by 2. That won't give you the right answer. This will give you the right answer, however, and we'll show you why. So first, you have to find the amount of time it takes for when she drove from her home to her office. So she drove 50 miles over 75 miles per hour, which equals 2/3 hours. Then for our trip from her office to her home, she did 50 miles over 50 miles per hour, which means that she only took 1 hour. And so that means for the total trip, back and forth, she took 1 hour plus 2/3 hours. So 1 2/3 hours to drive to and from work. And since we know the whole entire trip is 100 miles, we can put 100 miles over 1 2/3 hours to get the mph, or miles per hour, of 300 over 5, which is equal to 60 miles per hour. And that is our average speed. So remember, you're not just going to add average speeds and then average them like you usually do. What you want to do is actually find the times and the distances. So speed was just one example of a rate. When a fixed quantity changes over a set time, then that is a rate. For example, right here, we have delta x, and delta means that there's a change. So change in x over time, that is a rate. For example, you might have miles per hour, or words per minute, maybe even centimeters per second. So let's look at this example right here. Jason can type at a rate of 40 words per minute. How long will it take to write a 2,000-word essay? So the first thing you're going to do is, just like conversions, you want to first put whatever you know and then multiply that by conversion factors. So we know that we need a 2,000-word essay. And what we're trying to get in the final answer is how long, so minutes. So we want minutes as our last conversion factor up here. So we're going to do 2,000 words times 1 minute over 40 words. And we know that the words are just going to cancel out the units, and we'll only be left with minutes. So 2,000 times 140, 1 over 40 equals 50 minutes, and that's our answer. Alright, so now let's do a challenge question and use everything that we've learned so far. So Tom can paint Mr. Thatcher's fence in 6 hours, while Huck can paint it in 5 hours. If they work together, then how long will it take them to paint the fence? So the first thing we want to know is the rate, basically. How many fences per hour can each person paint? So Tom, since we know that it takes 6 hours to paint the fence, we know that it'll take 1 hour to paint 1/6 of the fence. And for Huck, it'll take 1 hour to paint 1/5 of the fence. So what we want to do is add them. So we add 1/5 plus 1/6, and that equals 11 over 30. So that means that they can both together paint 11/30ths of the fence in 1 hour. And now we want to say that we want to paint one fence using this rate to find how long it'll take. So we put one fence over 11 over 30th fences per hour, which equals 30 over 11, which finally equals 2 8/11 hours. Alright, so that is all for this lesson. Thank you so much for watching, and don't forget to like and subscribe. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!